Hello viewers, welcome back to the Math in Motion. Today we're going to talk about we want to show that alpha hat is blue. What I mean that is blue is that we need to show that alpha hat is the best linear and unbiased estimator of alpha. Today, as we know that alpha hat is the same as having y bar minus beta times x bar, and we know that for us to get the y bar, our y bar is the mean, the same as having summation of yi over n, and we know that our beta is the same as having summation of ki yi, where ki is the same as having xi over summation of xi squared. Now, today, we shall be just in need to show that our alpha hat is blue. First of all, we shall need to show that it is best linear and unbiased. Today, let us begin with showing that alpha hat is linear. We have started showing that alpha hat is linear. Now, first show that alpha hat is linear, we shall say from the definition of alpha hat, which is the same as having y hat minus bx x bar. As we know that alpha hat, y bar is the same as having summation from yi over n, yes, then minus the beta x. The beta is the same as having summation, okay, the same as having x bar. Now, summation of ki, where ki we define it as x over xi, then yi, that way. Now from here, I'm saying that yi is constant. I can pull out the summation, I put it outside. I'm putting out the summation to put it outside. Then into the bracket, I'll have 1 over n minus, then I'll have x bar ki, then yi. Because yi is constant, yi is common both sides. I'll put it outside, and then I'll have my alpha hat equal to this one. Therefore, from here, I just conclude that alpha hat is the same as having summation from 1 over n minus x bar ki, then yi. And hence, I have shown that alpha hat is linear, because I'm saying that alpha hat is a function of yi, because these are constants which are here, which I have to multiply with ii so as I get alpha hat. By showing this, I have shown that alpha hat is linear. Yes, I think we are together. Now, for any questions, I say you keep notifying me in the comment section, I'll be able to answer. Now, for the second part, we need to show that alpha hat is unbiased. Now, that shows that alpha hat is unbiased. Remember, something to be unbiased means that its expected value is the same value. As in, if I said that alpha hat is unbiased, therefore its expected value is going to be the same as having the value of alpha. Are we together? Expected value is the same as having alpha. As in, if alpha hat is unbiased estimator of alpha, therefore if I get the expected value of alpha hat, I need to get the alpha. Now, therefore, we need to show that the expected value of alpha hat is alpha. Now from there, our second step, we can find that, we can show that our alpha hat is unbiased. Roman 2, we show that alpha hat is unbiased. Yes. How to show that alpha hat is unbiased? We said that we need to find its expected value. But remember, we said that alpha hat, from doing alpha hat, is the same as having summation of 1 over n minus the mean times ki, yi. But we always know that our yi is the same as having alpha plus beta xi plus the error term ui, I wrote ui like that, where yi and xi are variables, and then ui, it is the error term. Alpha and beta alpha is the intercept, and then beta is the intercept. Alpha is the intercept and beta is the slope. Now our task is showing that the expected value, i.e. here I'm showing that the expected value of alpha hat is the same as having alpha. This is what I want to show. Now from there, I can easily show it, but I just need to first expand this one. Then from there, I just say alpha hat the same as having summation of 1 over n, yes, minus x bar ki. Now yi is this one, is now alpha plus beta xi plus ui, which is our error term. Yes, from here we are opening brackets. Just opening brackets from this step. If we open brackets, we shall say that alpha hat is the same as having summation. I put summation here. Now I multiply 1 over n times everything. Here I have alpha over n plus beta xi over n, now plus ui over n. Then I multiply everything times this side. Here I have minus alpha x bar this way. Now ki. Now this times this I will have minus x bar beta ki xi, and then lastly this one times this one I have minus x ki ui, that way. Now from there, I'm going to provide this summation to everything inside here. I'll have alpha hat to be equal to summation of alpha over n. Now plus this beta is constant, I have beta outside. Now summation of xi over n. Now plus summation of ui over n. Then minus alpha and x bar constants. Then summation of ki. Then minus x bar and beta constants. Then I have beta x bar. Then summation of ki xi, that way. Then minus x bar, this is x bar summation of ki ui, that way. I think now it's making sense. Now from this step I was saying that for any value, since if I'm summating for only a constant, if I'm summating from I up to n for a constant, I just multiply n times this constant. Therefore here alpha hat is going to be the same as having alpha. Now from this step here, we see that the mean x bar is the same as having summation of xi over n. Therefore, instead of me writing this one, I'm going to write just x bar times beta, same as having x bar times beta. Yes, now plus now summation of ui over n. But now remember our ki is xi over summation of xi squared. Now if I want to get summation of xi, summation of ki, just like this, the same thing as having summation of xi over summation of xi squared. But remember xi is the same as having summation of x up to xi minus x bar over summation of xi minus x bar all squared. But you know that sum of the difference from the mean is always 0. Therefore, we know that the summation of ki is always 0. Now from that thing you've seen that therefore the whole of this becomes 0, and then we shall ignore it. And then another thing I want to show you that from this step here also, if I have summation, if I say that summation of ki xi, the same thing as having summation. Remember we said that k is xi over summation of xi squared, but now x times xi, and this is the same thing as having xi squared summation over summation of xi squared, and this is the same thing as 1. Therefore from there I conclude that where the summation of ki xi is 1. I think you've seen it. Then I will say that this is 0, then this is going to be plus minus this is going to be minus x bar times beta, and then minus x bar here, summation of ki ui. Now for that step, we are saying that this x bar and this x bar cancels. Therefore, we mean that my alpha hat is going to be the same as having alpha plus summation of ui over n. Yes. Now minus x bar summation of ki ui. Now from that step, I think we can conclude and find the expected value now. Now from this step, allow me first put off this, because this, you know everything here. If I try to put off this, because we know these steps I think we've seen them. Now I want us to see how we find the expected value of this thing. Now I'm going to show you how to find the expected value. Now remember, if I have my alpha hat equal to alpha plus summation of ui over n, yes, minus x bar, yes, summation of ki ui, that way. And I'm interested in getting the alpha, the expected value. Therefore, it means for me I have to put the e of alpha hat. Now if I get the e of alpha hat and I see that it's the same as having alpha, therefore I will say that our alpha hat is unbiased. Therefore, from there, it's easier for me to get the e expected value of alpha plus summation of ui over n minus x bar summation of ki ui, that way. Now if I distribute this expected value to everything, this is the same as expected value of alpha plus, now this expected value and the summation can enter inside this. I have the summation of e of ui out of n minus x bar summation, since x bar is a constant, and then this expected value can enter inside the summation here. It's going to be ki, then expected value of ui. I'm saying that since the summation sign is commutative, this expected value can enter inside of summation and becomes ui, and then ui this side. But now what we have to note that the expected value of an error term, note that the expected value of ui is 0. Therefore, if the expected value of ui is 0, it sends this value to 0 and then this value to 0. And therefore, I'll finally say that the e of alpha hat, expected value of alpha hat, is the same as having the expected value of alpha, and then we know that the expected value of a constant is always that constant alpha. Hence alpha hat is an unbiased estimator of alpha, as we can all see. I think also this is simple. For any questions, please feel free to contact me in the comment section. I will be able to answer. Lastly, we need to show that alpha hat is best. Okay. Now, for us to show that alpha hat is best, it means that we shall need to show that alpha hat has the least square. So it has the least variance. Something to be the best, therefore it has to be having the least variance, means it has to have less variation in it. Therefore, we need to show that alpha hat, the third topic, the third chapter today we'll talk about, we need to show that alpha hat is the best. Meaning that it has the least variance. Now from there, we shall also begin we shall find the variance of alpha hat, and we see whether it has the least variances as compared to the variance of alpha star. Let us begin with finding the variance of alpha hat. As we know that alpha hat, we have already seen that alpha hat is the same thing as having summation 1 over n minus x bar ki times yi, and our yi is the same as having alpha plus beta xi plus ui. Yes. Now from that step, I think we can easily But this time round, I think shall not expand it. Just leave it that way. Now remember, if I want to get now the variance of alpha hat, remember from what we know that the variance of if I'm finding a variance I'm finding variance of x. I'm just finding variance of x. Just example, variance of x, and our x is the same as having like ax, the same thing as having just variance of x, the same as having a squared variance of x. Therefore, this rule is what we're going to apply on our value here. I'm saying variance of, let us call it y. Okay, variance of x, yes, variance of x, and then this is our equation. So I just say that variance of x is the same as having a squared variance of x. Therefore, also as we're going to apply this one here. Therefore, since this is our constant, we shall square this constant and then multiply by the variance of yi. I'm saying this is the same thing as having summation of 1 over n minus x bar ki. Since this is our constant, I have to square it times the variance of yi. But remember yi, we shall note that yi, we shall need to note that yi is equal to sigma u squared. We just name it to be, okay, variance of yi to be sigma u squared. We just call it to be sigma u squared. Now from here, we can expand our bracket here by saying that if we expand, we shall just square everything. So I say 1 over n squared minus 2 times 1 over n times x bar ki over n, then plus x bar squared ki squared, everything times sigma u squared, the variance of y. I think I also together on that step. But remember, we still have a summation mark here, summation. We still have this one here. Now also here, I'm going to try to enter this summation inside here. But we say that if I enter the summation for a summation, now it's the same summation of 1 over n squared. Now minus 2x bar over n summation of ki. Now plus x bar squared, because it's a constant summation of ki squared, like that. Everything times sigma u squared. But now we say that if I'm summating a constant, I just multiply n times this thing. Therefore, I have 1 over n. Now minus, but it says summation of ki is the same as having, summation of ki is what? Summation of ki, we are saying summation of ki is what? Summation of ki is 0, yes, because we said summation of ki, we said that our ki, remember our ki is the same as having xi over xi, summation of xi squared, like this. Now if I want to get summation of ki, I put the summation here also. Then it's the same thing as having summation of x, capital Xi minus x bar over summation of capital Xi minus x bar, like this, everything squared. And then I get to know that the difference, some of the difference from the mean is 0. Here up is 0, and then therefore the other thing has to be 0. Everything is 0. Therefore, I'm going to say that this is 0. Then if I say this is 0, therefore I just need to write this step here, that plus x bar squared summation, yes, summation ki squared, everything times sigma u squared, that way. Now our task now is expanding this one, ki squared, and then we see what we get from there. Now from that step, if we try to expand ki squared, if we say that ki squared, if I put off this also to get enough space, I say that I remember summation of ki squared the same thing as summating of xi, but xi is squared now over summation, yes, summation of xi, because remember ki is summation of x. Okay, this is the same as having summation of xi squared times summation of xi squared times squared. What are we together? Remember ki is the same thing as having xi over xi squared, but the summation here. Now if I square everything, then I will square everything here, then I square everything here. Therefore, 1 will go with 1, and then I'm going to remain with 1 over summation of xi squared. I think we are together on that step also. Now from here, instead of me having this, we just write that this is the same thing as having 1 over n, yes, plus x bar squared over summation of xi squared. Just like that, times sigma u squared. Now from here, I can easily, let me simplify this to be simple. If I get the LCM, just multiply LCM is n summation of xi squared. Now if I divide, I have here summation of xi squared, xi squared. Then if I divide here, I have plus n x bar squared, and then this is sigma u squared. You may take your variance to be that way, or one may also see further simplify this. Let us further simplify this and we see. Then if I want to, if I try to simplify it further, that thing, I will have something like, if I try to further simplify this, remember that summation of xi squared is the same as having summation of capital Xi minus x bar squared. And then if I square everything, this I have summation now of xi, capital Xi squared, minus, yes, 2 capital Xi x bar, then plus x bar squared. Then if I try to put the summation for everything, I have summation of capital Xi like this, minus x bar is a constant. I have 2 x bar summation of xi, and then plus, then summation of x bar squared. But as we say that for a constant, we just multiply times n, and then you know that, remember our mean x bar is the same as having summation of xi over n. Now, from to get this one, I just multiply times n inside to get summation of xi. Now from here, I just say that this is the same thing as having summation of x capital Xi squared minus, then this is going to be now, since this one is going to be, it's going to be nx bar. They have now 2 nx bar, now plus this is going to be nx bar squared, but this is going to be squared also because I have nx bar times x bar times 2 is going to be nx bar squared. Therefore, finally I want to have summation of capital Xi squared to be minus nx bar squared. But remember, this is summation of small xi, everything squared like this. Now to relate to our question, therefore, for me to have, if I have summation of small xi squared plus nx bar squared is the same as having summation of xi, capital Xi squared, and then this is what we have here. Therefore, I can easily replace what we have here with just simply this. Therefore, I just say that I'm trying to say that our variance, yes, our variance of alpha hat. Therefore, from this step here, from this what I've seen here, that our variance of alpha hat is the same thing as having, instead of me having summation of xi squared plus nx bar, I just have summation of capital Xi squared out of now n summation xi squared, everything times sigma squared u. I think we've seen how we have arrived to that step. For any questions, please feel free to reach me via the comment section, and I think I said my number. Feel free to WhatsApp me or call me. I'll be able to help you. Now, since we have seen the variance of alpha hat, now I want us to assume, I want us to let a given variable alpha star, and then this alpha star shall compare its variance and this variance we've seen, and we see which one has the least variance. Now, from this step, I think we shall need to note this value here. Say that it has first note somewhere this value here, because it's going to be the past answer some question. This value, it has not this value. We say that our variance of sigma of alpha hat is the same thing as having 1 over n plus x bar squared over summation of xi squared times sigma u squared. I think if let us let a given variable alpha star, and we see whether its variance is going to be the same or whether it's going to be less than the variance we have. Then from there, we can easily say that our alpha hat is the best. Okay, from there, let us let our alpha star for it to equal to summation from 1 over n plus minus x bar, now for it ci times yi, and where ci, just define ci, where ci is the same as having ki plus bi, just like that. Now we shall do all the steps and we see whether its variance is the same or why it's less than that variance. Now from there, let's find the variance of alpha star. The same thing as having, I said, if you just square this constant 1 over n squared, so 1 over n minus x bar ci squared, then times variance of yi, and the variance of yi I said it's the same as having sigma u squared. Yes. Now this is the same thing as having now here. If I square everything, I have 1 over n. I have summation first of 1 over n squared, now minus 2 x bar ci over n, yes, and then plus, yes, I think plus now x bar squared ci squared, like that. Now sigma u squared, just like that. Now if I enter the summation inside here, we have 1 over n. Remember we did this first, then minus now 2x bar, like this. Now summation of ci over n, yes, and then plus. Now if I enter the summation inside here, I'll have x bar, then summation of ci squared, yes, like that, everything times sigma u squared. But recall that we said the summation of ki is 0, therefore also summation of ci equal to 0. Therefore whether is ci I put there is 0. Therefore I'm going to remain with that 1 over n, yes, minus, because this is going to become a 0, then plus x bar summation of ci squared, like this, now times sigma u squared. But recall that ci is the same as having k plus I, but ci is the same as having ki plus bi. Now if I replace it inside here, I'll have 1 over n plus x bar summation of, now I'll have ki plus bi, like this, squared, everything times sigma u squared. I think on the same step. Now if I open brackets here, I'll have 1 over n plus x bar. Now I open brackets summation into ki squared plus bi squared plus 2 ki bi, just like that, but everything times sigma u squared. Now if I want to get space, I can put off this again, because you have been following. If I put off this, for me to have enough space to write everything I want. Now if I open brackets, now I have opened brackets, now I'll have, if I put a summation to everything, this is x bar, then I want to remain with that. My variance, remember I was talking about the variance of alpha star, so it should be the same as having 1 over n, yes. Now if I open bracket, I have plus, yes, x bar summation of ki squared, yes, now plus x bar, summation of bi squared, then plus 2 summation of ki bi, everything times sigma u squared. But now from here, we need to know that from here you can easily say that, but summation of ki bi from here just say that, but summation of ki bi. But if I want to do summation of ki bi is the same thing as having the summation of xi, because remember ki is xi over summation of xi squared times b. But remember now, summation of this one is going to be the same as having summation of x I minus x bar, which is xi, over summation of xi squared, then times b. But now times bi, sorry. But remember I said the summation, the sum of the difference from the mean is already 0. Therefore, it's going to be 0, and then the whole thing is going to be 0. Therefore, the summation of bi is going to be 0. Therefore, the whole of this term is going to become 0. Therefore, I'm going to be left with 1 over n, yes, plus x bar, yes, plus x bar. From there, now summation of ki squared, yes, summation of ki squared, then plus, I think, x bar, summation of bi squared, times sigma squared u. Yes, but I think here you had a squared. I think I forgot a squared here. Then it's the same as having a squared here, squared here. Here you had a squared. I think we forgot it. Just put it here. Now from that step there, we shall just need to if I divide, say, 1 over n plus x bar squared summation of ki squared, just like this, I put a sigma squared here u, then plus x bar. This is x bar. Yes, x bar summation of bi squared, also this one times sigma squared u. I get to know that this was our variance we had. Sorry, here we had no x bar squared. Sorry, we had no squared here. Now from this step here, if I try to expand this k squared here, remember from the previous one we said that, but summation of ki squared is the same as having, we're summating of, now remember ki is the same as having xi, then I'm squaring it, divide by summation of xi squared, then I square it again. The same thing as having 1 over summation of small xi squared. Therefore, instead of me writing the whole of this, and we are saying x bar divided by this, I think we had a squared here. Oh, I'm sorry for making contradictions in my saying I had a squared here. Therefore, I'm going to say that this is the same thing as having, instead of me writing the whole of this, I'm going to say x bar times squared times 1 over this one. Therefore, I just say this is the same thing as having 1 over n, yes, plus now x bar squared over summation of xi squared, like that, sigma u squared, yes, now plus x bar plus x bar summation of bi squared sigma u squared. And then we shall see that this is our variance we had. This is the variance of alpha hat we had, because I said it has keep it here. This is the variance of alpha hat we had, plus this other value we don't know, sigma u squared. Now if you compare, this is the variance of alpha star, remember. Now if you compare the variance of alpha star and variance of alpha hat, we get to know that the variance of alpha hat is smaller than the variance of alpha. Therefore, we say that therefore the variance of alpha hat is less than the variance of alpha star, and hence alpha hat is the best estimator of alpha, as you've seen with ease. I think for this we have been observing all of us together. Members, for any questions, just feel free to reach out to me. I will easily explain. Since you've seen that the variance of these two are not the same and this is less than, because to have the variance of alpha hat, we need to add these two values, the variance of alpha hat plus the variance plus this value. then we just say that these things, the variance of alpha hat is just the variance of alpha star. And then you say that to show that alpha hat is the best, you show that it has the least variance. Therefore, since the alpha hat has the least variance, then you say that alpha hat is the best estimator of alpha. Thank you for watching. Please share the video, like, subscribe, and comment. Members, I want to take this opportunity to thank friends who have helped me put out this video. I want to thank Bajen Zuril, I want to thank Nyanzi Trevor, I want to thank Namakula, Angela, Nankawira Bridget, English Hurricane, and very many others who have enabled me to perform this duty. I just ask you to keep sharing the videos, like, share, and comment. And for any questions, just feel free to talk to me, and I'll be able to answer. Thank you for listening to me. I remain Shaka Anwar, the Master Tutor.